In this video, we are going to go over the setup and control of a 3-phase brushless linear servo motor using the TITAN-1VX controller. Here we have the encoder connected and the 3-phase motor wires connected. 24-volt DC power is connected. Communication is done through the USB. The first thing to do is to go to the communication and check the communication. Next, check to make sure that the encoder signals and index channels are coming in okay. It is waiting for the Z index trigger, and as the motor is moved, the index is detected. Next, let's go to the motor database wizard. Select the 3-phase linear brushless motor. Magnet pole pair distance is 12 mm, and the encoder resolution is 0.5 microns. For the motor name, we will enter IKO. For the rated voltage, let's enter 24 volts. The rated current is 700 milliamps. Max current is set to 1.5 amps. Confirm that no Hall sensor is used. Since this is a small slide, let's set the strength to small. Run the auto detect. Let's put the motor in the middle. The first thing the routine will do is to move the motor and find the direction of the motor with respect to the encoder signal direction. The motor is moved and the encoder direction is found, as well as the encoder index channel. Next, the electrical parameters will be found. This requires the motion of the motor, so let's set the limits of the motion. Go to the negative end and set the position to 0. Move slightly out and set this as the minus limit. Move to the other end and move slightly away and set the position as the plus limit. Let's put the motor back in the middle and let's proceed with the electrical parameter detection. Okay, so it's done. We can see that the motor EMF constant is found, as well as the resistance and the inductance values. We also see that the encoder index was detected. Encoder resolution is 24,000 counts, which corresponds to 0.5 micron encoder resolution for the 12 mm pole pitch. The setup looks good so far. The next thing that we need to do is to find the mechanical inertia and friction values. For this one, we will use manual tuning. The soft limit check is enabled. Let's go to the next step. Since this is a short stroke motor, we will set the increment to small. Let's perform the auto detect. Okay, the detection routine found the inertia and the friction values. Let's apply the newly found values. Let's run it again at higher acceleration. Let's apply and do it one more time at a 30,000 acceleration value. Let's apply the new values and we are now done. Now, let's perform some motion. So, I'm going to disable the soft limit. Servo is off. Let's move by hand and find that the approximate range of the motion is about 42,000 counts, or about 21 millimeters. Let's move to 1000 and move at 50 millimeters per second. Set acceleration to 5000. On the other location, let's move to 35,000. Speed is 100, acceleration is 8,000. Let's try going back and forth. Let's write a small program. Set the speed and acceleration. Let's move back and forth between 1000 and 35,000. Before running, let's make sure the servo is on and wait for the servo to be on. Download and then upload to confirm the program. Let's run this program. Set it to make it a little bit faster to 300 millimeters per second. Okay, the motion looks good. This concludes the tutorial of quickly setting up the IKO microlinear stage with the 0.5 micron encoder using the TITAN-1VX controller. We saw that the setup and motor parameter detection are done easily in a few minutes, and we were able to do some quick motion tests. I hope that this tutorial was helpful.